Hey slackers, welcome back. I hope you're all doing well and you and your families are well and staying safe. I think about you guys a lot. I really hope that we can get back into school eventually. I don't, everybody keeps saying, oh, we're done for the year, but I'm trying to be optimistic. I'm trying to think, hey, maybe by the end of May when the weather starts to get warm, it'll get better out. So we'll see. I appreciate all your hard work. You guys are doing great, giving me assignments and whatnot. I just want to go over the fact that when you send me assignments, I'm checking them like they're homework. Please try to ignore the grades, so to say, going through Canvas. I'm not using Canvas for its grading. I'm literally just using its format to upload videos and assignments for you guys. That's it. I'm not using the grades in there. So if you're sending me stuff on Remind and then it's showing up as zeros on Canvas, ignore the grades on Canvas. I'm checking it on Remind, keeping track like I do in class, and it's a homework assignment. In the case where I give you something that'll be graded, which we're going to do this week, it'll be great to have a graded assignment, like a quiz, so to say, on this format, because you're going to have my videos to look at. You're going to have your homework lessons, the pictures I've sent you, and text messages, everything to look at. It'll be like open notebook quizzes all the time. So I really feel like it'll be very fair. All right, we got one more thing we have to talk about, which is the empirical normal rule. So let's get rocking and rolling. So if you take out your notes, it was number 7 in the notes packet, the empirical normal rule, and it's the last thing. Okay, we've done CVAR, we've done range rule of thumb, and now we did Chebyshev, now we're going to do the empirical normal rule. So basically, I want you to understand that Chebyshev's theorem only applies to distributions of any shape, okay? So Chebyshev's theorem, and again, if you have your notes packet still, you can write this in the notes packet. But on this worksheet for video lesson 4, I included it in case you don't have your notes packet anymore. Chebyshev's theorem applies to any distribution regardless of its shape. And what does that mean? We talked about shape of a distribution. Specifically, when you look at its bar graph or its line graph, is it right skewed? Does it get small to the right? Is it left skewed? Does it get small to the left? Remember, they had weird names like J-shaped, reverse J-shaped. Is it uniform, the same? Is it bell-shaped? Chebyshev does not discriminate. You can use it for anything you want, okay? And Chebyshev has 2 main points. 1 minus 1 over k squared, and then it has the 2 percentages. 75% is within 2 standard deviations, and 88.89 is within 3. Now, whenever it says, so when the shape is, this is very important, bell-shaped or normal. If they say it's normally distributed or bell-shaped, you're going to use the empirical rule. Okay, the following empirical rule applies. So the first one is, so now you had Chebyshev, who was in the 19th century, the 1800s, and he came up with two percentages. 75% is within 2 standard deviations, and 88.89 is within 3. And then later on, the empirical rule came about, a little later, and they were able to fine-tune it down to 3 different percents, which is what we know today and what you've used in Algebra 2 trig, where approximately 68% of the data falls, W/N is within 1 standard dev of the mean. Approximately 95% of the data falls, W/N, within 2 standard deviations of the mean. And then the last one is approximately 99.7% of the data falls within 3 standard deviations of the mean. So, what does that mean? Just making sure that we're recording here. Yes, we are. Okay. So, basically, if it's normally distributed, it's more exact, and you have 3 standard deviations. And that's why when we started out all of this, I told you the magic number is 5. Anything bigger than 5 is too big, because really they only have things down to 3 standard deviations as it is. Okay, so let's take a look at what we're doing. Example 1. The average delivery charge for a refrigerator is 32. Give me a fancy word for average. Mean. The mean is $32. The standard deviation is $4. In which at least 88.89% bells and whistles should go off. Ding, 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 ding. Anytime you see 75 or 88.89, that's Chevy Chef. Will lie. Be sure to explain your results. They want you to find the range of values. So if it's 88.89%, what's the range? So this is review. And 88.89 means it's Chevy Chef, and it's 3 standard deviations. So literally you're going to do the mean plus 3 standard deviations, and the mean minus 3 standard deviations, because if it's within, it's 3 above and 3 below. And if it's above, you add, and if it's below, you subtract. Okay? So basically, 32 plus 12 is 44, and 32 minus 12 is 20. And don't forget to write your sentences. So 88.89% of delivery charges lies between $20 to $44. Okay? And that's it. That should be review. We did this the week before school closed. We did this last week. I did a few like this in a video lesson, and I gave you a few for homework. So hopefully that's easy peasy. All right, let's put that aside. Let's look at number 2. Number 2, we have the average national SAT score. So here we go. Now things are going to get interesting. Is 1019. So I have average is a fancy word for the mean. If we assume it's bell-shaped, whenever they say bell-shaped or normal, this is the empirical rule. Remember, there's 3 parts of the empirical rule, okay? We said 68% is 1, 95% is 2, 99.7 is 3. You got to know those. And the standard dev is 110. They want to know what's the percent that's above 1129. Above. It's going to feel kind of similar to what we were doing last week with Chevy Chef, where we did max minus mean, difference divided by dev, gave me the K, and then you plug it in. The only difference is sometimes it's not a max. Sometimes the number falls below the mean. So remember, it's bell-shaped, guys. So it looks like this. And when it's bell-shaped, the mean always goes where? In the middle. So the mean is 1019. So where would 1129 be? Is 1129 bigger than 1019 or smaller?
What's that?
1129 is bigger. So if it's bigger, would I add the standard dev or would I subtract it? I'm going to add it. So if I do 1019 plus the standard dev, there it is, 1129. So I added the standard dev once. So I'm at 1 standard dev. But remember, the wording of the empirical rule says it's within 1. So it's 1 above and 1 below. Is that 68%? They don't want to know what's the percentage that falls within a range of numbers. They want to know what's the percent that's above. So really they want to know this part here. Okay, so think about it. If this part's 68 and I want to know one of the tails, what do we know percent is always out of? It's out of 100. Very good. So if I do 100 minus 68, you get 32. And then remember, there's a tail over here and over here. So I'm going to divide by 2, and you get 16%. Very good. So I can say that 16% of SAT scores falls above 1129. And that's your answer, ladies and gents. All right, let's try another one, part B. Okay, part B says what percent, so again, I want to know what's the percent that's above 799. Now again, you got to think about it being normally distributed. Where does the mean always sit? In the middle. And then where would 799 be? Would it be above the mean or below the mean? That's right, it would be below the mean. How do you go below? Would you add or would you subtract? You would subtract the standard deviation to get below. So I'm going to start out subtracting. 1019 minus 110, and you get 909. And then 909 minus 110 is 799. There it is. So how many standard deviations did I go? I went 2. Now remember, if I'm within 2 standard deviations, 2 standard deviations is, hi baby, is 95% with the empirical rule. But they didn't ask us within. They asked us above. So this one's a little tricky. I know part of the above here. They want this whole thing above this time. This whole part above. So I know the 95%. How am I going to figure out this one other little tail? Very similar to how I did it up here. What is percent always out of? It's out of 100. So 100 minus 95 is 5%. There's 2 tails, so I cut it in half. And I now know there's another 2.5% here. So now what do I do with 95 and 2.5? I add it to get my answer. Sorry. So the answer is 97.5% of SAT scores falls above 799. Yes, you have to write the sentence. All right, let's just try one more. I need about 5 more minutes of your time here. So we have, trying to see here, what was I going to do? Your homework, so I don't forget, is in the text pages. I put that up last week, text page 140. I believe it was the assignment that went with video lesson 2 and 3. And I want you to do 41 and 42. That is my cat's tail, if you're catching it in the video, by the way. So it's text page 140. Oh my God, I can't write. 41 and 42. That's your homework. Okay, so let's take a look. The average amount of time students spend doing homework is 10 hours per week. Average is a fancy word for mean, so that's 10 hours. We assume the standard deviation is 2.5. They want to know what's the percent that they spend more than, that it's above 17.5. Now, they didn't say anything about normally distributed or bell-shaped. So we're not doing the empirical rule, and they actually say in the next sentence to use what? That's right, Chebyshev. So we're going back to 75 and 88.89. So let's follow the steps. Max minus the mean, difference divided by the dev. That gives me my K. And then you plug it in. And that's how you get 88.89%. Now, the weird part is they don't want to know how many's within a range of numbers. They want to know who's above this. So it's kind of thinking of like the tail, what's left over on the top. And we drew our normal curve, except for I can't draw that with this one because it's not normally distributed. So I'm going to do 100 minus 88.89. And you get 11.11. And you remember there's 2 sides because it's within. So we divide by 2. And you get 5.56. All right, so we have 5.56% of students spends more than 17.5 hours per week doing work. All right, so part B is a game changer because now they're going to say it's bell-shaped. The minute it's bell-shaped, we don't do Chubby Chef anymore. We do the empirical rule. So remember, the empirical rule has 3%, 68, 95, and 99.7. They still want to know more than 17.5. So it's going to be very similar, except for now we're going to look at the normal curve. The mean always goes where? In the middle. And where's 17.5? Is it bigger than 10 or smaller? That's right, it's bigger. So am I going to add or am I going to subtract to get bigger? I'm going to add the standard deviation. So I'm going to do 10 plus 2.5. That's one standard deviation, 12.5. Not there yet, I have to get to 17.5. Add another one. It's at 15. Still not there yet. That's two standard deviations. Let's go one more time. So I get 17.5. Okay, so I'm at 3 standard deviations. Now within 3 above and 3 below, according to the empirical rule, is 99.7%. But they don't want to know within, they want to know above it. They want to know this guy. So what is percent always out of? 100. So I'm going to do 100 minus 99.7. And you get 0.3. And then you remember there's 2 tails left over. So I do 0.3 divided by 2. Now, all of this you could do on your cell phone calculator. And that's 0.15. And that's your answer. So now I just got to write my sentence. 0.15% of students spends more than 17.5 hours per week doing work. Okay, so I hope this clears it up a little bit. I tried to do just one problem of straight empirical rule. And then I showed you one problem where it's going to be the difference between Chubby Chef and the empirical rule. All right, so again, your homework is on the text pages 140. It's written very sloppy here. I'll rewrite it. And you're going to do numbers 41 and 42. It's the last 2 questions that we haven't done yet. Again, send me a picture on Remind, upload it on Canvas. I don't really care. Ignore the grades on Canvas. I'm not using Canvas as grading. Any assignment I've given you so far, I'm checking it as homework. And what I plan to do next is putting up a video going over some of the homeworks. And then I'm going to assign you a review sheet, so to say. And the review sheet will look extremely similar to the quiz, quote unquote, that'll be due on Friday. So whatever we do on the next video, well, maybe the next video I'll just make it a review. So on the next review, I'll do a review and then you'll have the quiz attached to it. The beautiful thing about it is you have me literally sitting in the palm of your hand so you can replay it over and over again and look at the notes to help you do the quiz. So hopefully you will all do wonderful on it. That will be graded as a quiz. All right. I love you all dearly. I miss you. Please be careful, be safe, be smart. Stay in as much as possible and wash your hands and don't put your hands in your face. All the things we spoke about before school closed. I'm still doing well. The baby's getting big. I'm getting bigger by the day. And yeah, everything's okay here at the Sakaro house. I know a lot of you have asked, and I love you all for asking. I miss you. And I had a couple of requests for me to do the pledge, Sakaro style, for my second period class. So I'm considering that request. I'm putting it on the table. All right, I love you guys all. Have a good one. Take care. Brush your hair.